Hey guys, what's up? Eddie Aho here with KissAnalog.com. Today we have a product that was sent to us free of charge. It's really nice. Now, by the way, I'm not being paid for it or anything like that. They just asked me if I wanted to review a meter from Kaiweets. I'm not sure how to pronounce that, but I said sure. So they sent it. So you know what we're going to do? It's a current clamp meter. It's pretty cool. I'm going to bring the camera over. We're going to show the meter. And we're going to test this Counterpoint Pre-Amplifier. We're going to open it up. We're going to do some testing inside it. Kind of have some real life testing while we review this meter. Okay? Alright, let's bring the camera over. Oh, hey, by the way guys, this is a gift we're giving away on Father's Day. Yeah, it's coming right around the corner, huh? Anyway, we're going to give that to a Patreon to kind of show some, you know, give a thumbs up to the Patreons, and for as little as $1 a month, you can be a Patreon. But anyway, here's my pitch. Alright, let's come over and check out the meter. Okay, so let's take a look inside this. Well, first of all, there's the model number for this thing. Package here. And we've got, this is nice, it's colored. Okay. There's, yeah, nice colored manual. Okay, here's the spec. There we go, if you want to take a look at that. 0.5% DC accuracy, that's pretty good. There's the other page. Alright, we'll just put that back in here. It looks like there's room to put the leads in this pocket as well. Okay, let's pull these leads out. Okay, these are your typical PVC type leads. Most leads are, unless they're the nice silicone type. But you know, PVC is nice because it's robust, strong, and it's durable. And we got these little protective caps. Let's just take them off now. And these caps are actually good to keep when you store, so you keep your contacts clean and you don't squish these guys. Then we got our Cat 3 little protective caps here. Those kind of hold on snug. They're kind of a soft feel to them. And you know what? These probes actually are kind of small. Some people like these small kind of probes, so I don't see people usually complaining. They usually complain about them being too long. Okay, here it says 10 amps max and 600 volts Cat 3. Or here's the CE and the double insulation. They almost look like they come apart, but I've seen these kind before. They don't. It's kind of interesting how they're put together that way. Alright. Just set those aside for now. Okay, we got our temperature probe with the banana plugs. That's fine. These are okay, and then our meter. And there's our batteries. That's good. Came with batteries. Okay, let's put those in. Looks like just one screw to take off the back. Make sure I don't lose that thing. Okay, there's a metal capture. That's nice. And that's not retained. You know, there's very few retaining, you know, meters with retaining screws I've seen. Now the batteries are kept away from the circuitry, so it's safe to, you know, you're not going to have batteries leaking into your meter, and if there was something bad to happen, it's, you know, it's all contained. Okay, let's go ahead and take these two guys out. Okay. Oh, there it goes. Okay, just feels like it's clipped in up here. Yeah, there it is. Okay, so there we go. This guy has a nice ridge. It's capturing that channel right there. Then this back piece has a nice ridge here that's captured in here. And the boss looks like it goes up in here, so it looks like it's made pretty durable. This little zigzag things to capture the wires and keep everything inside. Alright. Well, you're not measuring current through the meter, so you don't have to worry about those big HRC fuses. It does have some PTCs down here for input voltage protection. It has some MELF resistors. And there's your big chip. Let's see if I can get it a little bit closer to this. Alright, there's a little closer look for her. You can see here the 600 volt Cat 3, and over here the 600 amps, which I think that's just, that looks like it's just reproduced on this side. And you want to see inside the jaw. So this little piece right here sits down inside there. Then here's your non-contact voltage antenna. So that's probably these wires coming down here. There's a couple sets. 2 of them would be for the coil and 2 would be probably for the non-contact antenna. Okay, we got 2 screws here and 2 screws there. And there's your crystal oscillator and your buzzer. Alright, let's put it back together. Nice indications inside where your batteries fit, the polarity. Alright guys, I think we're ready to plug this thing in and do some testing. Let's go ahead and put our meter leads in. Now it shows positive on this side, common on this side. Back here, there's no indication. Now these are right angle. I thought that was interesting, but I think it's to provide strength. You can't pull that out. At least it'd be very hard. If they just didn't have the right angle, you'd pull them out a lot easier. But these, yeah, you can pull on those. So always make sure your leads are pushed all the way in before you use them. And if you wrap your meters around this way, eventually they're going to break here. That's just a common thing with with current clamp meters that people wrap their leads. So if you do, make sure you hold your hand out here, give some relief to those wires. So there's a little loop there, and then wrap them so that they're kind of loose up here. Then when you finish, you can just put them through the loop or something like that maybe. But it doesn't fit in the case as nice either. But anyway, yeah, just be careful of this part of the wire, getting damaged over time. Okay, so it's been a while since I've had this powered up, a long while. It's been in storage for some time. So let's go ahead and put this into low Z setting. Okay, and like I said, you're not going to get stuck in between it. It's pretty positive clicking. Okay, then we push our function to go to the beeper mode, or continuity mode. There's no power applied to this, so don't get nervous. Okay, we're going to come over to fuse, take off this little boot, and check the continuity here. Hey Andrew, not like this. Just a joke. Anyway, when you do continuity reading, it's nice, purposeful connections, not this fire stick method. Okay, and our power cable comes in here. So if we're trying to diagnose and see how things work, it looks like it comes in. I see a green wire coming up here to the chassis, which it should, and then for the transformer there's a white wire going to chassis. And then, but what I see interesting is on this capacitor, you see that earth ground symbol. So what that would mean, at least I would think, I could go from here to chassis. I'll go to the screw right here. Well, I can go to the middle of this. Well, there's kind of enamel on it. Huh. There it goes. Yeah, there's kind of an enamel coating on the top. Oh, look at that. It goes orange too. That's nice. Yeah, Morse code, huh? Okay. So yeah. So it looks like we have a nice chassis connection to our ground. Now up here, this transformer has these wires here, the blue and yellow, going to 348 volts AC. So we're going to have some high voltage here that we can look at. And as a matter of fact, that's rated for 450, so I wonder if that's where that voltage goes. Then this one is 19.6 volts, so I imagine this one goes to one of these caps. So, alright, we checked continuity, right? You know what, let's go to this 20 ohm resistor and see if we get continuity check. Wow, you know, there must be some circuitry in parallel because we're getting 7.6 ohms there. You notice the glass tubes? So this is a hybrid preamp. That's why we have the high voltage. And look, we have some poly caps. And you know what? Let's check some capacitors. So let's go to function. Here, I'll turn on the backlight so we can see. It says nanofarads there. Okay. Can you see that better? Alright, let's go. You know what, before we do this, always a good idea, even though I know no voltage has been on here, let's just check to make sure we don't have any voltage. Now it says DC. Alright, let's... Is that 2 volts DC? That's interesting. Let's go to low Z and see if we can leak that off. Yeah, if there's any voltage, it's not there now. Let's go back to that other voltage just to see. Okay. Yeah, it's down to 1.5. You know what? I think there's some residual voltage on that cap, so let's just hold it here for a moment. See if we discharge something. Okay, let's go back to the voltage. Yeah, it looks like there's just a little bit of residual voltage on that thing. I think we're going to be okay. Let's go to capacitor. And function to nanofarads. Okay, right there. Okay, 52 microfarads. This thing's rated for 47, so I would believe that. You know, let's go to poly cap over here. .27 nanofarads, and that says 0.02 microfarads, so that looks right. Let's hit this little guy. Alright, I'll go on this little guy right here. 25 nano. It says it's a 0.007. I wonder if it's in parallel with this guy. They look like they're physically placed where they could just be in parallel with each other. I think they are. So we got 0.02 here and 0.07. Wow. So yeah, that sure does look like they're in parallel, doesn't it? And these are Wonder caps, by the way. So it's supposed to be a really high-end cap for high-end audio. And these are WEMAs. It'd be hard to get to those right now. Alright, so there's a capacitor, small one and a big one. And let's see what else we can do. Alright guys, the power is turned on. I've got the power cord in, but the power's not turned on. So let's go to voltage here. Go DC volts there, okay? And let's see how I can do this. Maybe, I wonder if I can clip on this. I don't think you can see it. Can you see that meter? Okay. Now what I'm going to do is I'm going to go from this fuse to the chassis. Whoops. Let's get to AC. Oh, look, goes amber, 120 volts. Okay, so we got 120 volts sitting in our fuse. The switch is in the off position, so as soon as I turn it on, we'll get some voltage on this cap and some other places. So let's go ahead and put it in DC mode, then I'll turn on the switch. Okay, we got it in DC mode. Okay, tubes should be, they're probably not going to burn too hot, but okay, let's go to that big cap now. This is high voltage, so I got to be careful. Wow, look at that. Lights up amber, 430 volts. Geez, guys, 420. Okay, it's kind of dropping a little bit. But yeah, that's a lot of voltage for a 450 volt cap. That should be derated a little bit more, I would think. 422. So it started off kind of high and it dropped, but that's still pretty high for a 450 volt cap. I'm not sure if I like that. Let's go to AC and see if there's any ripple on that cap. No, it just, once it settles in, it doesn't show any ripple. This is a pre-amplifier, so it doesn't draw a lot of power. Okay, if I go across the diode here, okay, 170 volts. That's across one diode. Yeah, so that's pulsating DC at that point. 170 volts RMS. Okay, what else can we do, guys? Let's do some current. After all, it's a current meter, right? Okay, let's go ahead and put this in. It's got a 600 amp range and a 6 or 60 amp range. And then it says low pass filter up there too, so if here, I'll turn the light on so you can see. Okay, there's Hertz, there's low pass filter, AC, there's AC. Okay, then we're back to Hertz. So let's go back to AC. And then see these wires right here, they're brown and blue. You can't see that angle. I got to get the other angle. Okay, I'll come in here. Okay, it's only 0.216 amps AC, if you can see that. Okay, now you know how it's kind of hard to put it down there where you can see it at the same time? That's why you have that hold feature, right? I can go down here, hit the hold button, that hold button right here, and then look, there's the reading. So yeah, that's what's nice about that hold. You might not be able to see the meter when you're reaching in to grab a wire and trying to be careful not to touch anything. So pull it out, hold it like that. Now you know what? Let's turn it off. Okay, I turned it off, and what I'm going to do is I'm going to clip on it and I'm going to put it in max mode. Okay, so there's max. So let's see what we capture. I'll turn it back on. Okay, hold on a sec. Reach down here. Okay, I didn't hear a beep or anything, but let's see if it caught something. Yeah, it sure did. Look at that. And by the way, you can turn off your power sleep mode by holding the function key down when you turn on the meter. It also has a min capture. If you think your voltage is fluctuating, you can go to min and capture a minimum. But I don't think we're going to have a min. Let's see, I'll push the button. I don't think I have to push it when it's in max or min automatically. I just kind of redone it. See, the H goes away. Let's try that again. It's probably not going to measure a minimum. Hey, maybe if I turn on, you know what? I'll turn off the switch and turn it back on. See if it captures something. No. Okay, I'll put it on max. Now look, it still shows the last reading. That's kind of nice, but I have to hold it down. Oh, maybe that's why it didn't capture anything. Okay, go to min. Let's try that again. Turn it on. Yeah, no. Didn't really capture a minimum. But it did capture a max. So it seems like it doesn't matter which mode you're in, it's going to capture something. So that's kind of cool. Can you just hold that down, zero it out? Nice. You know what? Let's go back and see if we can capture some hertz, okay? See if you can see that meter. It's not a great angle, huh? Okay, let's see if you here, I'll turn on the backlight. And then here I'm going to go from chassis to the fuse. Yeah, there's 60 hertz. Now I wonder if I can get frequency ripple off the capacitor. No, there must not be any ripple on that thing. Okay, I'm going to the capacitor. Okay, I saw something there. Hey, you know what, guys? Check this out. If I just put the leads down near this voltage on this transformer, look at that. If I put it next to them like that, you can see how it picks up the frequency. Which, by the way, reminds me, let's check let's check the NCV. I don't know if it matters what mode I'm in. Okay, here I think I push this down, hold it down for a second. Okay, and then see it turns on NCU or NCV. It's kind of funny, up here it says up there it says NCV and down here it says NCU. Okay, if I go, okay, that's high. Get this angle right here. See, there's a L for low. Yeah, so it depends on how close you are and get a higher low voltage. There's a fuse there. This is a voltage regulator here on the front panel. That should be low. That should be DC. It's just giving me a low voltage signal. Yeah, so it does give you a warning for DC voltages as well. There's power coming in. Of course, that's gonna light it up. If I go up to the power switch up here, or the fuse, and here's a power cord. So when you're bringing the power cord to it, oh, that's interesting. You get up inside here, it gives a really good reading. Oh, that's interesting. Alright, hey guys, by the way, when you saw me taking the current readings over here, I was on one wire. You can't go like this and get a current reading, okay? So if I go to current here, you can't get a current reading that way. Okay? When you do this, let's say the hot lead's going this way and then the neutral's returning. So those fields, those magnetic fields cancel. So there's no field for these, for this loop to pick up. This is essentially like a one-to-one transformer. You know, you got one winding here, one winding here. You could have a whole bunch of turns in here, I don't know. But let's say you have 100 turns inside here and this, it's 100 to 1 turn. But you don't get any field pickup when there's no field. So, hey, by the way, let's check out the flashlight. Okay, there we go. Probably can't see anything with my bright lights, huh? Yeah, it's alright. A lot of these multimeter flashlights aren't super bright, but yeah, that does a trick. I mean, I still got some lights on this thing. There you go. Now maybe you can see a little bit better what it looks like. So yeah, that works. Okay, I hit the off switch on this thing and pull the power cord. Let's check that big old cap and see if there's any voltage on it. Yeah, there's still 81 volts. So, see how it's draining off? Down to 63. That's still that's kind of voltage that can bite you if you just stick your fingers in there. So we'll let that drain off, okay? Alright, so we said this is true RMS, and it's a 6,000 count meter. That's pretty nice. Let's go ahead and turn that on, and I've got 1 volt RMS coming out of my generator right here, okay? And let's see what frequency it's at right now. Okay, there's Hertz. Whoops. It's 999.9, so it's pretty much 1K. Okay, let's go back to the AC volts. Okay, we're 0.9 volts, so really 1 volts. That's the low pass filter. Look, it's already filtering. Let's go back to we'll check that in a minute. Let's check out this AC. Okay, we got 1 good volt, right? Okay, I'm going to increase the frequency. There's 2K. Okay, 3K. So that's 0.7, you know. So yeah, it's good for 1 kilohertz, but really look good up to 2 kilohertz with the sine wave. So now we're down 3K. Let's go to the filtered version. Well, here, let me. Okay, there's a frequency. There's a 3K I've got coming in here. Here's the filtered LPF. Look, we're down 0.5 volts, 0.4. So if I go to 4K, look how that voltage drops off. There's 5K, it's down at 0.2. So 5K is down at 0.2. That's DC. Okay, here's AC. And yeah, we're at 0.2 there as well. So yeah, we're way past the roll off, but that's pretty good. That's showing you how that filter is working. And the true RMS works up to about 2K. Alright guys, I got a square wave and I got 1 volt RMS coming through at 1 kilohertz. So it's 1 kilohertz. And look, the low pass is down to 0.8 volts. So it's already doing a little bit of filtering. and here's our AC 0.937. So yeah, we've filtered off about 0.1 volt, some of those harmonics with the square wave. So yeah, that low pass filter, yeah, it's doing its job. Alright, let's try this temperature function. Okay, got the light on. Starts off in Fahrenheit, 75, and if I just hold that, well, looks like I'm safe from COVID right now. Let's go ahead and touch a tube. These tubes don't get super hot. They're not running super hot, but look at that. It's going up. Let's go to Celsius. Yeah, so it's getting a little bit warm. Not bad. If I touch it, yeah, that's about all it is. Not too bad. This transistor on the back side of the box here. See this transistor right here? If I come over here, and you can see it takes a minute to get. I'm trying to hold it there. It's got a temperature. It's not too hot. I can feel it with my fingers. It's not too bad. Go back to Celsius. So yeah, the tube's probably a little bit warmer. I don't know if there's a way to turn off the display from turning off. I didn't check that in the manual. Yeah, so just in closing, it has a nice feel. This wheel's nice and, it has a nice solid click to it. Seems to be, nice grippy, the way they made the plastic features. I mean, for 30 bucks, that seems like a winner. Hey guys, so what do you think of this meter? Pretty cool, huh? And by the way, thanks for all you guys watching and subscribing. Because of that, these guys offered to send me a meter. I think that's pretty cool. And after this one, I think they're going to send me something else. See how it goes, right? Alright, hey, thanks a lot for watching, and thanks Patreons. Now remember, this is a 6,000 count, true RMS, has low pass filter for the VFD type drives, noisy motors or whatever. And so it has that cool filter, but it also has the low Z for the ghost or phantom voltages or stray voltage, whatever you want to call that. And so it's pretty nice little, now it's category 3 too, right? Not category 4. So, I mean, hey, for 30 bucks, that's all you want, right? That's great. And it's really safe because you can just clamp on wires this way versus, having to put it through the meter. And you can read currents a lot higher than 10 amps too, safely. So yeah, these clamp on meters are really nice, and if you do any work around the house, electrical type work, I recommend doing this versus putting current through a multimeter. Okay, alright, we'll see you next time, guys.